Hello and welcome to LiveAction's presentation of Software Defined as Eating the WAN. My name is Christian Bard. I'm the VP of Marketing at LiveAction. Darren Kimura, our Executive Chairman, is not able to join us today, so I'll be joined a little bit later by John Smith, our Chief Technology Officer. LiveAction has been working on Software Defined WAN since 2013. Back then, the team recognized there were a few gaps and issues developing in networking which would only become more pronounced as SDN began taking hold. The key gaps are visibility, analytics, and vendor lock-in. So we set out to develop a product that would help address these issues. Initially, we thought software defined would take hold slowly, just like about everything else. But fast forward to today, software defined is presenting itself as a sea change. It's disrupting the rules and the incumbencies, and in particular, bringing massive change to the wide area network. For example, there's no shortage of SD-WAN 101 type presentations. On Bright Talk alone, we found 206 SD-WAN related webinars. When you add in webinars hosted by the different technology companies, we have found over 1,000 webinars on the topic. There are 106,000 SD-WAN videos on YouTube. These run the gamut from SD-WAN basics to what is SD-WAN. And thousands from technology companies discussing their unique approaches, and hundreds from consultants who analyze and cut the data in every which way. The most viewed videos have well over 100,000 views, and there is a combined 5,600 hours of SD-WAN for your binge watching pleasure. A search on LinkedIn will result in 8,900 people with the term SD-WAN in their titles. Over Memorial Day weekend alone, over 30 people updated their profiles to include SD-WAN. These job titles range from sales to product management to test engineers to software developers to executives, and include my favorite title, SD-WAN Disruptive Technology Solutions Consultant to Superstars. How about that one? SlideShare has become one of the largest online repositories of points, and here you'll find over 122,000 SD-WAN related presentations with 2,500 slides on the topic being uploaded in May and 200 being updated over the weekend. A quick search on Google will produce over 22 million SD-WAN search results, and the pay-per-click AdWord cost for SD-WAN is now $43. In comparison, the PPC for WAN is $9. And the term insurance, which is one of the higher generating revenue words, is around $54. So we're tracking 37 SD-WAN technology companies. Across these 37 technology companies, we have also tracked an investment of over $1.8 billion. Speaking for the projects we are involved in or aware of through our partners, we're tracking 500 POCs, proofs of concepts, and as for actual installations, earlier this month, one of our partners announced they've passed 400 customers deployed on their SD-WAN solution. Another one of LiveAction's partners reported having over 16,000 deployments in branch offices, and LiveAction's LiveNX is being used on over 300 corporate SD-WAN production environments now. Now, back on November 2012, Cisco acquired Meraki for $1.2 billion, which Cisco said was designed to address the rapidly occurring shift to cloud networking, a solution that is easy to deploy and manage. So you could say history is repeating itself as we see Cisco acquiring Viptela here recently. Cisco says Viptela's technology is cloud first with a focus on simplicity and ease of deployment, while simultaneously providing a rich set of capabilities and scale. Our view is that the combination of Cisco's IWAN solution with Viptela's cloud-delivered solution and subscription models should help Cisco retain its leadership on top of the WAN markets. With IDC predicting the SD-WAN market to reach $6 billion by 2020, SD-WAN growth will continue. In summary, there's a ton of information available from many, many credible sources. Over 37 technology companies fighting for their place in the market, backed by almost $2 billion in investment. Hundreds of production SD-WAN deployments and hundreds more in POCs right now. And big companies acquiring smaller companies. So what's next? Well, I'd like to introduce John Smith, our CTO, who will help navigate the complexity and take a deeper dive on SD-WAN technologies.
Thanks, Christian. So I'll be talking about the SD-WAN technology and do a little overview of the planning process, the deployment approaches, and technology selection. So on the screen, you see on the right-hand side a typical network that our customers are deploying IWAN to, or SD-WAN from various vendors. And it involves a bunch of components here, including sites, data center, are using a public cloud like AWS, what SaaS applications are using, and the users. So this is the context in which SD-WAN gets deployed. And there's numerous deployment approaches. So in terms of physical appliances, virtual appliances, CPEs, virtual CPEs, controllers that actually manage all this as well. And then there's various on-premise type deployments, managed deployments, service provider provided services, and whether it's a brownfield or greenfield. And with close to 40 vendors, you can see that there's a gamut of different deployment approaches that each one takes. In terms of like the technology selection, there's financial aspects to it. There's also the functionality that you're looking from the SD-WAN, whether it's just application performance and picking different routes across your multiple transport for better costs, but also it could be security as well. And there's other criteria such as scalability, how complex is the system, is it managed or is it deployed, do you manage it yourself? And also things such as the legacy infrastructure that the SD-WAN has to fit into. And also the staffing in terms of the network engineers that will manage the system, their familiarity with particular technologies or particular vendors. And there's a whole slew of webinars and white papers from each of the different vendors on the technology selection criteria, so I won't go into too much detail. But what we see our customers doing when they deploy SD-WAN is the planning process, the deployment, and thinking about the management plan and also the tool infrastructure. So in terms of planning, the various SD-WAN components have to be determined in context of your various sites and data centers and applications. And how exactly do you want to interface to your existing infrastructure? So whether it's a smaller site or if it's a larger campus, and how that connection is going to be done. Do you already have existing infrastructure that can support SD-WAN? For example, Cisco IWAN can actually work on top of your existing Cisco ISR G2s, ASRs. Other vendors also have appliances and virtual appliances that can actually add the SD-WAN capabilities, and others are new virtual CPEs or edge devices that have to be added. So there's a lot of consideration that has to be done on how to interface to the existing infrastructure. And the last portion is really about the transport. So you have current service providers and internet access. So as you plan SD-WAN, is the planning of, do you add additional service providers or do you reduce like MPLS usage to reduce cost? So there's a lot of concepts and ideas on how to actually deploy SD-WAN. And another complexity is the public cloud. So we see a lot of our customers using AWS and Azure. And if there's direct connect, how are you going to connect the SD-WAN from various sites and campuses to the public cloud? In terms of deployment, we see various customers doing it in different ways, but typically what happens is they would do like a proof of concept with a smaller set of sites. So once an SD-WAN vendor is chosen, they'll go to this phase of determining what portions of the network, what the deployment phases are done to actually deploy the SD-WAN. And typically we see it starting out in a smaller set of sites and then growing over time. And then there's a set of deployment planning that has to happen with the cutover. So if you're running the existing services with the SD-WAN, what is the plan to do that? And as you bring on the new transport, what is the transition that has to happen? And the third part that's important is the management plan and the platform for monitoring and analyzing the SD-WAN. So the SD-WAN vendors definitely have management tools that are required to deploy and run it operationally. But we see a lot of customers requiring, extending the visibility into the SD-WAN, but also beyond, as SD-WAN doesn't live in a vacuum. It connects to other portions of the network, as we can see on the right-hand side. So how does that integration happen, and how do you manage that and get visibility and troubleshoot through that whole system? So a typical SD-WAN deployment steps that we see our customers doing is on day 0, doing an assessment before SD-WAN gets deployed and understanding what are the existing capabilities of their WAN, what are the baselines, what kind of applications are running, what sites, how many users, service provider SLAs. So trying to get an understanding of their network, their WAN, and then using that to pick certain sites or subset to actually do the initial deployment of SD-WAN. And then day one, in terms of actually deploying SD-WAN to become operational. And here, the key aspect is making sure that there's assurance and verification that the actual SD-WAN and the policies that you set is actually working to what you expect it to do. And then day two operations, so day-to-day monitoring and alerting, making sure that you also have assurance as you do optimization of the policy and as you plan to add additional sites or applications or expand your SD-WAN, a way to understand if the policy is working at scale. And the third aspect is really about troubleshooting. So we've seen deployments where the least visible portion of the network gets blamed. So if you don't have good visibility into the SD-WAN, if there's application performance problems, we see this blame happening into the portion of the network that people don't understand. So getting coverage into the SD-WAN, especially since it's a new part of the network, is very critical, or else we see a lot of initial blaming happening into that part of the system. So in terms of SD-WAN management, there's definitely platform and tool requirements. And for SD-WAN, there's the need for configuration, deployment, and management. And all SD-WAN vendors provide their vendor management tools, which is required to set up policies, determine intent, deploy it, and troubleshoot it. But beyond that, having the capability to have visibility and assurance, no matter which SD-WAN vendor you may go with, and also which devices and network that you connect the SD-WAN to is actually pretty important. And as we looked at all the different customer deployments, we saw 3 different challenges of actually doing SD-WAN monitoring, and we kind of categorize it in these 3 categories of visibility and assurance, scope of coverage, and is the platform built for analytics. And I'll go into more detail on the next slide. But as we talked about, software eating the WAN, it's really also about future planning for software defined. So SD-WAN is a step in the journey, and we see software defined, already in the data center, but we also see it coming into the access layer. And you need to make sure that when we think about SD-WAN management, that you also plan for the future when SD software-defined access comes on board. How do you get management across all these different systems so you get easier management, visibility, assurance. And we also see a lot of customers using public clouds, for example, Amazon AWS, and you can make these virtual private clouds, VPCs, and you can make very complex networks, purely software defined, and you can connect this back to your data center, to your various campuses and sites across the SD-WAN. So it's becoming much more complex, where we need a platform that can manage and understand this hybrid cloud environment. So in terms of the 3 challenges that we see as customers deploy SD-WAN, the first is visibility and assurance. So in terms of assurance, understanding if the system and policy is doing what is intended. And the SD-WAN system will make decisions based off of application performance and other criteria, including costs that you put into the policy based off of your intent. And it'll make automated decisions, and trying to understand if that particular behavior is what you expected, it becomes very important. And as you make changes to the policy, is that change actually affected into the system as well? So we see assurance as being very important in this process. And visibility is one of the key ways to understand what that system is doing. And what we see is, as SD-WAN gets deployed, the operators become somewhat detached from the day-to-day operation of it, since it's automated. So providing the right visibility so that they can understand what the system is doing, so that they can explain to their management, what the system is doing, if there's a problem, what that problem is, and being able to rectify it becomes very, very critical. especially since these SD-WANs are making real-time decisions in multiple aspects. Understanding that becomes very, very much harder. And then, like I mentioned, without the visibility, the network engineers and others will blame the portion of the network that has the least visibility. So getting coverage into that becomes important. The second aspect we see is the scope of coverage. So the SD-WAN doesn't live in isolation, and it has to interface to other router switches, firewalls, wireless devices. So having a breadth of coverage multi-vendor becomes important to get a more end-to-end view of application traffic, since it has to cross different systems and different devices. So this definitely helps in terms of triaging problems and also troubleshooting, where you can actually see the handoffs happening from the access layer to the WAN, and understanding, if, for example, if the application performance behavior changes, DSCP marking changes, why certain flows will go over certain service provider, what was the actual trigger that caused that, and was it actually triggered at the WAN, or was it actually in the LAN, for example? And then the third aspect that we see is the platform built for analytics. So SD-WAN vendors are great at creating the SD-WAN fabric, but it's not necessarily built for network visualization and analytics. And we see, 4 components to this platform typically. And on the right-hand side, you can see the typical design of an analytics platform. And at the very bottom, it's really about big data and the issues that big data brings. And one is, as you have an SD-WAN that's deployed in a very scalable number of sites, large number of distributed sites, having a solution that's scalable to be able to deal with that scale, and then be able to do retention of raw and also aggregated data in real time and also historical becomes important. But we also see a diverse set of data coming. Historically it's been SNMP, NetFlow, but now you need APIs to get REST information, JSON information. You need integration to other systems, wireless LAN controllers, Active Directory for identity. So it becomes much more important to be able to consume and ingest, much more data sources at scale. And then the middle portion is really about analytics. So correlating this diverse data set, but applying semantic information in terms of like understanding, where this data came from. Was it the WAN, edge, which service provider, what's the capacity of that, what site was it? So being able to correlate that information so that the end user can make sense of that. And then, being able to understand anomalies that are happening and applying machine learning to help us do that. As the networks become much more complex and to a certain extent becoming more black box and automated, applying machine learning we see as a better way to understand the volume and different behaviors in the network. And the last two are really about visualization and integration. So providing a platform that can provide situational awareness through exploratory and explanatory capabilities. Exploratory meaning, as you troubleshoot, is it giving you all the information required historically in real time and context to be able to debug these systems? And explanatory meaning, is there a set of workflows that are predefined that can help you to troubleshoot or understand certain things that are required? For example, WAN capacity is something that's always been being done, whether you have SD-WAN or not. Is that explanatory workflow already built in? And on the visualization, being able to provide that end-to-end, not just across SD-WAN, but as we get SD access into the data center and into your public clouds as well. So those are the 3 challenges that we see at SD-WAN. It's not really just about SD-WAN, but also the other parts of the network and also looking into the future. So just talking a little bit about live action and our solution LiveNX for SD-WAN. So we looked at all the different ways our customers are deploying, and the pattern we see is the day 0, day 1, and day 2. And we've crafted our solution to be able to do pre-deployment in terms of deploying our capabilities to be able to understand, what your existing WAN infrastructure looks like. And this helped our customers when they're deploying to understand, where do we want to do the initial deployment? How do we want to phase that in? Be able to select the pilot sites that you want to go with initially. And it also gives you a certain understanding of what that baseline is, so that as you deploy SD-WAN, you can compare the changes that are happening to the network. And day one is really about deployment. So as you're using the SD-WAN management tools to deploy, being able to visualize in very good detail, how that system is working, be able to actually see application paths, and correlate it back to various events that are triggering the path changes of applications as the SD-WAN makes automated decisions. So we see that as very important. Without the visibility, it looks like the system is making arbitrary decisions, but when you put it into context, it makes it much more understandable, and there's a trust that's built into trusting the automated systems much more. And it helps the network administrator visually validate how the SD-WAN works. Because at the end of the day, he has to be able to explain to his boss, how the system is working, how he wants to change that, and if there's a problem, be able to explain, what that problem was. And in terms of day two operations, there's still need for things like capacity planning and the usual WAN workflows that needs to be done, but also operational reports and alerting for the WAN capabilities, applications, and sites. And then we also have a capability for doing continuous application and user experience monitoring. So how are your SaaS applications working across any WAN, whether it's SD-WAN or not? So it's agnostic to the actual fabric. With that, I want to show a couple of demos. So using the Live NX capabilities, show an example of what that might look like for day 0, 1, and 2 for Cisco IWAN, and also for the Viptela solution. So it just kind of works well that Cisco is announcing the Viptela purchase. So on the Cisco IWAN side, we have integration with their controller using REST APIs, and we also get information from IPFix and SNMP and other data sets to give full visibility of that the system. And also similar on the Viptela side. So when you see the demo, you'll see that we can do equivalent on IWAN or Viptela. So with that, I'm going to switch over to the demo. So this is a high-level view of an IWAN deployment, and what you're seeing is multiple sites. So we have San Jose, Los Angeles, and New York, and you can look at all the different statuses, and you can drill down into a particular site like Los Angeles. And here you can see that it has a border router, and it's using to transport MPLS and internet. And you can see various metrics in terms of like WAN traffic using DSCP markings, or you could look at it from application perspective. So having a platform that can correlate SNMP data, but also IPFix flow data becomes very important, as we see a lot of SD-WAN vendors providing that data set. And also providing a high-level view of your system. So looking at utilization from WAN perspective, applications, and a simple map. And you can look at WAN-specific metrics in terms of like site utilization, certain application group, the bandwidth that's used, and being able to see which service providers are running that type of applications in much more detail. And then, having interesting visualizations that, is easier to understand. So we have a chord diagram that can show you over the entire WAN where the traffic is going to. So here it's basically showing you that the majority of traffic is going between Los Angeles and San Jose. And you can look at it from different aspects and drill down further into it. If you wanted to see more detail about Los Angeles to San Jose, you can actually split up that traffic. So you can imagine as you deploy SD-WAN, you're going to have issues from particular sites. So from Los Angeles to San Jose, what set of applications are actually running across that link? How are they classified in terms of prioritization? Which service provider is that application taking? And as we grab status information from the SD-WAN systems, you can actually correlate it to any kind of performance information. So, typically the problems that our customers run into, may be happening now, but typically it happens, previously. So having the historical capability with the detailed information becomes important. And in our systems, we can actually animate as we look at particular traffic, which service provider did it take, and what was the actual status of that application. And we see this as pretty important, as certain events trigger applications to switch paths. So providing an abstracted view, we found with our customers to be a very easy way for them to troubleshoot and understand and correlate back information. And you can drill down into any of these columns to get a regular time series graph as well if you're interested. But as part of your SD-WAN deployment, there's certain things that you still need to do. And one of the things that you would typically do is WAN capacity planning. There's other things that you could do as well. So this will actually give you like the 95th percentile change month over month. And as you look at particular key WAN interfaces, we can provide much more detailed information in terms of inbound, outbound bandwidth, peak utilization, inbound and outbound, and also application information, top applications, source destination IPs, DSCP marking. So just because we have an SD-WAN doesn't necessarily preclude doing WAN capacity planning, because this will help you determine like if you can actually cut back on MPLS and add more bandwidth onto the internet, for example, or other transport. So this will help with making decisions that can have pretty big financial impact on the cost of your WAN. Now I'm going to switch to a different view that's a little bit more detailed. So this is a very detailed topology view of a typical IWAN deployment. And this is the San Jose, which is like the main data center. And on the IWAN deployment, you typically have like a master controller, which is this particular router here. And you have two border routers. And it's a deployment that can scale. You can provide a branch border router per transport here, which is an example that we have here. On the branch side, like Los Angeles, this border router can actually take care of routing to two different transports itself. So this gives you a visibility into what the SD-WAN system looks like. It can help you with decisions in terms of like, do I need to break out this branch if it becomes too big into separate border routers? So having this level of visibility in terms of viewing the actual edge devices, which interfaces, which tunnels the actual SD-WAN fabric looks like becomes important. And then on top of this, being able to do the collection of specific IP fix, NetFlow, and also the performance information from IWAN into a visualization becomes important. So what this is showing is across your SD-WAN, the various applications that are going across this fabric. And this is useful in terms of understanding, does it match what you're doing in terms of policy? And a lot of times you want to see it in different dimensions. For example, I want to see it from a DSCP perspective. So are the markings and prioritization that's being done very important, and is it being preserved? And we've seen cases where certain markings that the SD-WAN system is doing gets remarked by the transport, like the MPLS layer, and gets coming out the other end unmarked. So catching those kind of issues becomes important, as we've seen cases where there's active monitoring being done by the SD-WAN system, and they require certain markings to make sure that that treatment through various transport is preserved. And then, that's getting remarked, and troubleshooting that was very easy using this tool. Other things we can do is, understand from a performance perspective. So, getting performance data of applications from the SD-WAN, we can tell that, particular applications are having issues across certain transports. So here, we're highlighting that there's a lot of jitter over the MPLS network. And you can drill further into this and get an understanding from these applications. For example, the Citrix traffic, there's a lot of retransmission. So grabbing this type of application performance that's actually causing the choice of routes becomes very interesting. And then you can drill down further into this particular application and understand that hop by hop, which devices is it taking, where the retransmission is happening, and then being able to project this back into the topology, knowing that at the branch it was okay, through the transport there were issues, and coming back to the data center side, it's seeing the retransmission. So it can help you triage, especially at scale and the complexity of SD-WAN, trying to understand where these issues might be becomes very critical. Just going back to the flow view here. So a lot of times, you want to understand what happened over time, and a customer will call in that they're having application problems, and being able to drill down into a particular edge device and understanding what the application flow happens is very important. And being able to see this historically becomes critical as well. So you can actually go back at a particular point in time, and usually what we see is there's actually applications that are running across the SD-WAN, and usually there's other traffic, web traffic or whatever, that's actually causing congestion or other issues of the actual critical application. So using this capability, we can actually play back, what happened through the edge device. So you can see that in context, what are the other applications, what are the performance issues that we saw over time. So right now I'm showing it in terms of applications, but I can also show this in terms of addresses. You can resolve this to DNS. We also have tie-ins to Active Directory as well. And we can do this in terms of performance as well. So if you wanted to see the color coding in terms of performance metrics, we can. So there's some network delay happening here. We can convert that back to applications, and we can drill down into SSL traffic that's having some network delay, for example. So having this level of granularity, is very, very helpful in understanding and seeing if the policy and its intent is actually working the way you thought it was working. One of the other things that we can do on top of this fabric is, run SaaS-based application testing. So you can imagine on this IWAN deployment, we have agents that we can deploy at a particular site like New York and Los Angeles. And this will do a page load test from that site to your SaaS application. So no matter which SD-WAN vendor you're going with, it'll take the particular transport and give you metrics in terms of availability of your applications. Is it seeing network latency? Is it seeing DNS latency or response time? And we can click on any of these to dig further into it. And this is very useful for understanding and triaging. In particular, is it a particular site issue, a particular SaaS provider issue, or is it a global regional issue? So using the page load tests that we can provide, we can see that we have availability, network latency, and you can see some peak response times, and you can drill into any of these to get a page load view. But you can also get a distribution of this. So you can see that our response time, there's a number of page load tests that we're doing that are getting very high response time, and also some availability issues. And we can also show this from a path perspective. So from the various sites, as you run these page load tests, we can show you the actual path. So you'll see these applications hitting your WAN edge, and then it's going to hit the SD-WAN fabric and going over various transport. But we can show you in detail what that actual transport, whether it's through MPLS networks or internet, will look like. So we can actually show you all the various service providers and transport that would actually take to get to Office 365, for example. So that's a little bit on the IWAN side, and I'm going to switch views to the Viptela side. So this is a high-level view of what the Viptela solution looks like. So it looks just like the IWAN solution. You can look at various sites. You can drill down into any of these sites and get more detail. And this is a particular V-edge from the Viptela side, and you can see the various transport it's using. You get the same metrics in terms of DSCP marked WAN traffic, applications, and you can also do the site-to-site analysis as well. So this is the entire Viptela SD-WAN solution, and you can look at which sites are talking to which sites. For example, Seattle's talking to Los Angeles. You could drill down further into that and get more detail in terms of like applications and other metrics as well. And I'll let that run. But we can also show you a more detailed view in terms of the topology. So this is a typical SD-WAN deployment for Viptela. And on the left-hand side, you can see the various management pieces. So there's a vBond, vSmart, and vManage. So the vSmart is really the Viptela controller, and the vManage is the management solution that provides the policy and configuration capability and monitoring. And you can see the three edges here. So we have a New York, Seattle, and Los Angeles. And we can actually grab IPFix information. They have very good data set that comes from the V edges. And you can see, pretty much equivalent to what you see on the IWAN side in terms of seeing it from an application perspective, looking at it from like a DSCP marking perspective. You could drill down into any V-edge and understand what the actual application flow looks like, which transport did it take, and the playback as well. So very useful in terms of whether you're using IWAN or SD-WAN. So that's a little bit of the demo that I wanted to show you. And basically what we showed you is a multi-vendor capability over various SD-WAN to be able to monitor day 0, day 1, and day 2. And what it comes down to is we're providing a universal translator. So this is the original Kirk from Star Trek here, and he's showing the legendary universal translator. And according to Star Trek, the universal translator is a device for translating spoken languages in real-time communication. So obviously, our ability to be able to take various vendors and being able to understand and explain what that system is doing is what we're doing here. And with this, the Star Trek and the Kirk and the crew of the Enterprise was able to explore strange new worlds, seek out new life and civilization, and boldly go where no one else has been able to go before. So this is kind of what our vision is to be able to be the universal translator for the various technology, whether it's SD-WAN or SD-Access. So this is a very high-level view of our process, where on the left-hand side, you can see all the various different data sets, how we ingest and collect it, do the analytics, and provide the visualization and integration to other capabilities as well. So if you can think of LiveAction as your universal translator for your network, no matter where you are, no matter what equipment you have, rely on NX, LiveNX to connect to your network and provide advanced visualization and analytics, but also future-proof your network against vendor lock-in. So you can see all the different vendors that we can grab information from and visualize. With that, we invite you to download the LiveNX and try it for yourself by visiting our URL, which is on the screen. Or feel free to request a personal demo. Just go to our website and there's a way to request a demo. So on behalf of Christian and myself and everyone here at LiveAction, we want to thank you for your time. So thank you very much.